In this video, we're going to talk about friction force. The equation for friction force is force of friction equals the normal force times the coefficient of friction. Or sometimes it can be written as the normal force times coefficient of friction. Same thing, sometimes it's just represented differently. And the frictional force is the amount of force required to move an object across a surface where friction where friction contributes. And so in the real universe, that's everywhere, right? There's always friction between things. So let's say that we've got I don't know, we've got a table here, and we've got a box that's placed on this table. Nice little box there. Make our legs maybe a little bit thicker on this table, huh? Why not? Okay. And we want to slide this box in that direction across our table. Maybe the table needs some thickness to it as well. There we go. Looks better. All right, so we're sliding this box across our table, and let's say that we know what the materials of the table are. You know, maybe there's a nice smooth wood finish on the table, and the box is I don't know, ABS plastic or something. And there are a lot of tables that you can look up online to understand what the coefficient of friction is for different materials. So let's say that we know that our coefficient of friction in this situation, mu equals 0.25. We'll just say that's what it is. And we know that this blue box here, let's say that weighs, so we'll say the force of the box equals 15 pounds. So if we were to look at this straight on, we've got the surface of our table here, and we've got a box right here. We know that the weight of that box is 15 pounds of force, and we want to slide this box in that direction across the table. So our equation for frictional force is normal force times coefficient of friction, or mu, and the normal force is just going to be the force perpendicular to the surface created by the weight of the object that's sliding across. So since we have a flat surface here, our normal force is just going to be straight up. If we had an inclined surface, you know, maybe the table was like that and our box was like this, the weight of the box would still be straight down, but our normal force would be in this direction, you know, perpendicular to the surface across which the object is sliding. But we're just going to keep it simple for this example. So we have a horizontal table, and we have a normal force that's pointing straight up, which is equal to the 15-pound force. And we could do a quick Freebody diagram to prove that. So say the sum of the forces equals 0. And if we look at the forces here, this yellow arrow I just drew there to indicate the direction we're sliding, so I'm just going to erase that for now. Say the only forces acting on this system right here is the force of gravity, or in other words, the weight of this block, and then the reaction force, or the normal force, on the bottom. So all we have is forces in the y direction. So this is 1, right? This is our force of the box, and it's in the y direction. And then we have our normal force, which is also in the y direction. We know that the sum of the forces equals 0 because our box is at rest. It's not moving, so sum of the forces has to be equal to 0. And so we would say that, let's see, the forces in the negative y direction is the 15, so we'd say that negative FBY, and then we have only a single force in the positive y direction, so that's plus FNY equals 0. Move FBY to the other side, and we are left with FNY equals FBY. So sure enough, they are the same. we know that FBY is 15, so FNY must also be 15. Or if you wanted to look at it as FBY is negative 15, FNY would be positive 15. So we'll say FNY equals 15 pounds force. So we know our coefficient of friction, and we know our normal force. Now we can plug those into our equation. So we'll say 15 times 0.25. So a quarter of 15 is it 3.75? I think 3.75. 2 times 3.75 is 7.5, and then 2 times 7.5 is 15. So yeah, I think that's right. So our frictional force equals 3.75. In other words, so let's talk about what that really means, the frictional force, right? We're trying to figure out how much force does it take to pull that block, or to slide that block in this direction. Well, it's going to take 3.75 pounds of force to slide that block. Now, there's a difference between static friction and kinetic friction, or static frictional force and kinetic frictional force. Static frictional force is always going to be higher. That is the force required to start an object moving. And then the kinetic frictional force is the force required to keep that object moving. Usually, we're going to be more interested in static frictional force, because that's going to be the higher one. That's going to be our worst condition. And we're going to need to know as designers, well, how much force is going to be required to get this object started moving. So more often than not, you're going to be calculating the static frictional force. And so that's what we've done here, is to look at that, the force required to begin moving an object across a surface.
If you found this content helpful, consider enrolling in our signature program at mypipelineacademy.com. Whether you're an individual interested in beginning a new career as a mechanical designer, or a company interested in training your new engineering hires, our signature program helps students develop the practical skills they need to be productive mechanical design engineers. Seating is limited. We hope to see you there soon.